Thank you, Biko.
Yes, we can see you.
Yeah.
Welcome. Thank you for your patience as well.
Yeah, thank you for the great introduction. And my name is Bahati, and my colleague Lillian. Yeah, we'll be taking you through the presentation, which the title is Improving Water Utilities by Using ArcGIS platform. And for the stability of internet, I'd like to switch off the video so that I can I can have the stable internet.
Okay. So
again, welcome everyone to the presentation. The title is Improving Water Utility Performance by Using ArcGIS platform. As I said before, as I introduced myself before, my name is Bahati from Arusha Urban Water Supply and Sanitation Authority, and my colleague Lillian, who will be, we will have the joint presentation for this presentation. The context for this presentation is, as it is displayed, we'll have introduction to GIS, how AUWSA came from up to now, and GIS improvement, how AUWSA decided and when did AUWSA decide to improve the GIS, especially using Esri products. Also, we'll see whether AUWSA is targeted to be in the coming few years, and which area especially AUWSA will want to improve to using the GIS. As well as there are some discussions I would like to ask Biko at the end of the presentation, maybe to take the lead to help us on the discussion. There are questions we are still figuring out, and we are consuming a lot of time to find the solutions of that. So I think it's the good time for now. We are over 100 participants to this conference. I think it will be, good time to find at least at least to get the idea of how to do it. We'll see at the end of this presentation. Yeah, as I said, the history of GIS at Arusha Urban Water Supply and Sanitation. Before 2014, AUWSA was using the hard copy, the paperwork to draw the maps of the area where AUWSA is serving. For instance, if there is new customers and new water source, AUWSA was using the hard copy, the paperwork. After going to the field, whether someone is memorizing the area and roads and the arrangement of houses, then after when he come or she come back to the office, they start to draw on a paper. It's a big drawing board, and so if you see from here, this is the paper showing the map of the borehole. This is the borehole, and there are also the key to that map, which referring to that map. It shows the area, the location, and something like that. For this, it was mainly for this hard copy, for this paper, was to register the AUWSA's assets. AUWSA is the abbreviation for Arusha Urban Water Sanitation, AUWSA Urban Water Supply and Sanitation Authority. So the main purpose for this map was to register the assets and new customers. Actually, after when the customer is applying for water, the surveyor goes to the field to visit the customer's resident. So he come in the office and start to map with using the papers and pen. So and for those who are very new to the water utilities, speaking of AUWSA of assets, I mean the water pipe and other fittings like valves, which water pipes used to used to transmit water from the source to the customers to the point of tapping of whether the customer is tapping. So this is the pipes, and in between there are many fittings, including valves. The valves are fitting which allows which enables the flows of water. You can close, you can open it, so it allows the flow of water, and it also, yeah, as I said, you can close it and open to regulate the flow of water. So in 2014, AUWSA decided to shift from this paper to GIS. So AUWSA started the house-to-house survey. Actually, the utility hired the team of surveyors to visit house to house and asset to asset. It was a big task, but thanks because they did a lot at that time. So they mapped a lot of customers and a lot of assets, as you can see from the photo. This is the big hotel in Arusha. It's called Mount yeah. And this was to register assets and the customer at that time. And yeah, and for data processing at that time, up to 2018, AUWSA was using the open source QGIS, as well as for data management, we are using also the open source database called the PostgreSQL. As you can see from the photo, these are location of the customers and pipelines. If you see you see the blue lines, this means that all lines represent pipe as the field, and the value of the utility is measured using the assets, not the number of employees they have or the number of nice cars the employee drives, but they are is measured by using the number of the quality and how good the assets have the utilities have. So at the points, the points are customers, the location of the customers, where the customers are. So up to that time, up to 2018, we found out there are some challenges we are encountering during the implementation. Specifically is the procedures, because in 2009, the government introduced the open performance review and appraisal system we call OPRAS. So you evaluate your employees, especially to the governmental organizations. You evaluate your employees by using this OPRAS, the open performance review and appraisal system. So from there, the surveyors also, they are being evaluated by using by number of customers they survey. And the plumbers also, they are evaluated by using the number of customers they have connected. So for surveyors and the procedures, when the customer requests for water connection, especially at AUWSA, when the customer requests for water connection, then they are being assigned to surveyors. So a surveyor visits the customer's residence, then they take the location, the geolocation of the customer, and come back to the office to map it. After mapping it, they prepare the invoice, then they send it to customer. After there, the customer pays for the connection. So for that procedures, it was a bit challenge to the surveyors, because you need to map a customer and give them the different status with the active customers. So for customers who not yet, just the surveyed, not yet paid, they were giving the status of new connection, and customers who paid for connection, they were giving the status for live customers. The issue was coming, like the procedures for these steps, for these stages. It was at the end, when a customer is connected, then a plumber brings back the files, the customer files who are connected, and brings back to the surveyors. So the surveyors, they have to go back to the system, to the GIS system, to the QGIS, and update the status from new connection to live. So sometimes it happens, the surveyors have so many customers to attend and so many customers to map. So it was taking time to change the status. And sometimes they were ignoring, because they are not evaluated by having very nice status in the GIS, but number of customers. So this is the picture showing the number of customers who are still on new connection customers. All these red dots, they were, or red stars, they are customers who were still on new connection customers. But in reality, there are a lot of customers who were already connected. So also we had the issue of missing correct information, specifically from water network and from pipe network and customers. So for the customers, example of these green dots, these are points representing the customer's location. So if you open one, I opened one and take the screenshot of this, you can see they highlighted in red. These are the informations filled in, which the information is in that point. So you can see from first field up to almost the last field, nothing were filled in. Instead, object ID, which is picking automatically, the only location is picking, only they provided the location for this customer, whether the customer is found. So this is the challenge, and you can see this is the only part, only one part. There was so many customers who are not, who were not filled in their information is in the field. Also from here, you can see, as I said, all lines represent the pipeline, and all blue lines represent the existing pipe, as the red lines represent the proposed line. So in reality, there is no this much proposed lines. You can even see from here, this is the active line and this is the proposed line. So the active line is connected to the proposed line. So the proposed line is, in short, if the proposed line is saving water, is the active line is getting water from the proposed line. So here you can find there is a incorrect status. This we found in that during that time before 2018. So even on the fields, there are very few fields, only distance and object ID, which is picking automatically, as I said, as well as the location. For the location, it is because for laying a pipe, you need the location and distance, whether you can whether you can request for funds to lay a pipe. So this is the detail, the informations from this selected pipe. Also we had challenge with, as I said, time consuming. From office, you go with the customer to the field, then from the customer to the office to map. That was taking so much time. Also, we missed out the leak registration tool. We don't have, we at that time we had no leakage registration. The leakage was only managed on one office, one small office with few employees, plumbers only, and the engineers from the respective sections. So others from maybe from finance, from accounts and from different offices, they had no clue of what is happening at the field, how how our assets they are on which conditions. So it was giving hard time to follow and to blame. You don't know whom to point a finger that we have high non-revenue water. What is the cause? What is the source of this non-revenue water? And things like that. And also for GIS, it was only requiring, if you have issues with GIS, you have only to ask the few employees who are really good at GIS. So it was not interactive. Anyone from other department was not able to follow and to use GIS, because it was requiring a high knowledge, a highly skilled people to work with the GIS issue. Yeah. In summary, for the introduction, for the up to 2018, the GIS at AUWSA, Arusha Urban Water, was used only for registration of assets and registering the new customers. So we got challenged because so many were at the utility were asking if it's true the GIS should only be used on asset registration and customer registration. Then the answer was no. That's where we reached out as East Africa to assist us and to see how we can improve our GIS using the ArcGIS products. From there, we decided to improve our GIS. We started with customer and meter survey, where we did specifically to those customers who were still on new connection status. We did the survey using survey 123 and we in collaboration with Workforce. Also, we introduced the leak reporting tool as well as valve assessment tool. For leak reporting, at least to have the overview of the condition and behavior of our pipe network. So at what condition and which pipe is contributing so much in leakage. And also we assessed the quality and the condition of our valve. Yeah, so we introduced it, we went far to introduce also the tool, the tool to new water connection, as well as to the pipeline extensions. Instead of taking the coordinates from the field and coming back to the office to map, then you can do the extension using collector app, ArcGIS, collector for ArcGIS. You can stream the extension of pipeline. The pipeline you can stream at the field using smartphone. The collector for ArcGIS, as the previous presenters said, this is the mobile application as well as this Survey 123 and Workforce. For new connection, we introduced the new connection, the new water connection survey, where we will see at the following slides, as well as we introduced the analysis of GIS data with ArcGIS Dashboard. The dashboard, as others said, it's used to summarize, to analyze the data. It's used to transform the data into information. So you have your data and it has to be introduced, it has to be changed, it has to be changed to information. So information is useful, but data is not useful. So we introduced the ArcGIS dashboard so that we can have the overview of we can have the information from the data available at the field. This is for GIS improvement, this is the leakage reporting. As you can see from the photo, from the picture, as I said, the blue line, these are the existing lines. And for here, the green line, these are lines, small, they are, the symbology were categorized by using the pipe size. Yeah, the interest here is the dots. The green dots showing the active, the repaired leakage, and the red dot showing the active leakage. These are leakage which are still leaking, and these are leakage which are already repaired. So this, from the picture, you can see the overview of at least the summary of the condition of your network asset. Assessing from here, you can know, it helps us also to identify the missing pipes from the GIS, because from here you can see like, there is a leakage without a pipe. So it's probably there is a pipe. So when a plumber is at the field and a supervisor, if they find a pipe which is missing from the collector, because they have their map in the mobile phones, so it's easier for them, it eases them to stream it direct, as I was saying. Yeah, this is the example of how leakage is being reported by data collectors from the field. Here is the data collector together with my colleague Lillian. So it is a video instead of, because we thought instead of practicing it, yeah, demonstrating is for the issue of internet, maybe it might be taking so long time to load. It's good to have the pre-recorded video. So here is the example of how they are. It's a demonstration of how they are reporting from the field. Here at the field, they found water, which is pre-assumed to be a leakage, and at the middle of the road. So yeah, they are reporting by using mobile and collect app for ArcGIS. So she's filling in the information you can see from afar. This is the zone 1 and other informations they are filling in. After submitting, it appears direct to the dashboard and to the ArcGIS smartphones. So it is helping us to increase to reduce the awareness time and to increase the efficiency of attending a leakage, instead of knowing of thinking like of waiting for the customer to call, there is a leakage here. So we can know very quick by using surveyors at the field. Also, for the new water connection, these we have this is the picture showing a map for new connection. This map, as I said, the lines represent the pipeline as the field, and the dots represent the location of the customers. We have for the orange, I'm not good at color. I think this is orange. For the orange, represents the surveyed customers, and for the yellow, you can see from afar, this is the yellow. There are few yellows. These are customers who are surveyed and paid for connection. The purple one, they are customers who have they are surveyed, paid for connection, and they already picked up the materials. Because the procedures for Arusha, if a customer pays, they are called to pick up the materials and start digging. So these are customers. For the purple customers, these are customers who already paid and picked up the materials. They are just waiting for connection. And the green one, the green dots represent the customers who are already connected. So these are live customers. Yeah. For practical part, this is the demonstration how it works for Arusha and the fields where the surveyors and plumbers fill in. This is the collaboration they do after a survey. Yeah. The surveyor, when he or she goes to the field, they report the survey the customer and submit in the collector. Then during the installation, the plumber go and edit the same customer to the field. So they edit the status. For here, this is a sample of this is the sample of a map which is used for surveying and new connection. So you can see for those who are new in GPS accuracy, the number at the top, it shows the accuracy. It is very accurate because it's almost it's 1.9. And for the handheld GPS, mostly they have the GPS accuracy up to 3. So this is more accurate. The higher the value, the higher the number, the lower the accuracy. And the lower the number, the higher the accuracy. So this means the radius, it diverges from the point where it's taken, it diverges from where you stand to by 1.9. So this is how the accuracy works. So let's continue with the demonstration. Yeah, this when they start the survey, adding a new customer, they give the name. This is the survey part. When the surveyors at the field, they do this, they give the survey, yeah, they give the name of the customers, they give the name of the surveyor, they give the survey date and usage of the connection. As I said, it is very collaborative. When a plumber goes to the field, yeah, this is the name, surveyor name, and survey date. When a plumber goes to the field, they find the same at the customer's location. When they see a dot, they can even search directly from the mobile, from the app. So if they search, they are directed direct to the customer. And if they don't know the location of where the customer is, they can navigate. So they can follow the route proposed by Google Map. Yeah, this is the customer eligibility. This is the zone of where the customer is located, and this is a reference number. So after that, when they submit, as I said, a plumber also, when they open the app, the point, they edit to edit the status and the name of the plumber who connected the customer. Yeah, the plumber opens again the collector. Yeah, finding the respective map, like new water connection plumber map. Yeah, the accuracy again 1.8. So this is very 1.9. This is very accurate. Yeah, a plumber starts to edit because at the point of connection, you know the account number. At the point of survey, the customer is still not yet given the, yeah, the customer is still not yet given the account and meter number, because the plumber, when they are at the field, they have the account and meter number. So they start to write in. For instance, here, this is the account. This is the account number and meter number. The name of the customer was already given was already filled in by surveyor. So it's here the plumber skips this and skips the surveyor name. What they write, they choose from the list the plumber name and name of billing officer who issued the meter, as well as the connection date. So this is how it works with the collector for ArcGIS. Also, we are using, for managemental level, we are using Explorer for ArcGIS as part of improvement. It's used to identify or to locate the missing assets from the map. Also to tell the respondent, yeah, it's used to tell the respondent the issues which needs to be fixed very quickly. This is here also the demonstration of how the Explorer for ArcGIS is used. You can see from, yeah, the way we are using it at AUWSA. This is the Explorer for ArcGIS. Then a map which is shared to that account. Then, as I said, the lines represent the lines represent the water pipes, and the dots represent customers. So I explained how the color of the customers, what does it represent? For the red color, for the black color, I didn't explain it on purpose. I will explain it here. So if we were at the field and there is you find there is a black dot, then the Explorer for ArcGIS should jump in and tell the one who fixed it, the one who reported it, like there are some issues missing. So for here, you write like, yeah, for here it written the invalid status, because if they have the invalid status, they should be in one of the three colors, but this they are in black color. So we give the name, what is it, and the notes. Yeah, like if we need to be fixed very quickly, suppose it is a big leakage. So we do it by using, we assign the plumber, we assign the supervisor by using this, by using Explorer for ArcGIS. Yeah, attend this very soon, because if you see and you visualize it, it's you who decide, who can tell like which important it is to attend it very quick. Then we share it. It allows to share as a to fill in. It is using the inbuilt markup tool, and to share it allows to share like a screenshot, or you can share as a, here it was shared to one of my colleague, Lilian Oserere. She will be presenting very soon, and it goes to in WhatsApp. So to open it, she can open by using, yeah, she can open it by using the Explorer for ArcGIS, or by using any tool, any mobile smartphone tool, which is, yeah, which is compatible and integrated with Explorer for ArcGIS. For us, we normally use Collector for ArcGIS to open this tool. Yeah, to open this the reported issue. Yeah, you can we can do share using as a, yeah, you can share as a screenshot, and to open, you can open as the Explorer or the Collector or field maps. Field maps, I think, as they explained, it was explained from Esri, it used to, yeah, as it was explained by Esri, it used as a collector for ArcGIS. Yeah, as part of improvement, also, if you collect the data, as people says, if your data is not shareable, then they are useless. So we don't need to have a useless data, but we need to have useful information. So the quick way to convert, or to have the data converted to information, analyzed to information, is using ArcGIS Dashboard. So the dashboard we have is for leak repairs, for new connection, as well as we use stone maps and web application to combine the different dashboards, which gives the complete analysis. So for this part, for this part of stone map and dashboard and web application, Lilian will talk over to continue with it. I will say a little bit about leakage repair and new connection dashboard. This is the new connection dashboard, which shows, it is a picture of new connection dashboard, which shows the number of customers connected, surveyed, because I said for the workflows, we start with survey, then after paying invoice sent payment, then we do connection. So this is the surveyor's dashboard. For today, up to the time we start the presentation, we had 3 surveyed customers. Total this week is we had 42 customers, and also these are the list of customers surveyed this week. This the map, as I showed before, the map represents the location of the customers and AUWSA assets. For here, it shows the percent. As I said before, we have the government introduced the open performance review and appraisal system, which is called, in short, OPRAS. So to evaluate the surveyors, how are they doing the speed towards the target, we use, yeah, because the appraisal, it is being evaluated at every half of the year, like after every six months of the year, then they evaluate and continue. But for us as a GIS, we decided to do the evaluation daily. So a surveyor can know like how do they need to increase the speed to reach the target given by the government. The water utilities regulator, we call for Arusha is AUWSA, and this is the percentage toward the target. For this is the number of the customers surveyed, Also here, the surveyors contributing this week, the surveys per week, per customers, so the number of surveys per surveyor for this week. And here is a summary of daily surveys per month. This is the 30 days. It shows every day. Like for today, 25 of March, as I said, like up to the time we started this presentation, it was 3 surveyed customers. So this links to this number here. This is also a video to show the demonstration. The video was taken before the picture, the previous picture. So this is the video to demonstrate how this dashboard works. As I said, this is the number and this is the list. You can scroll to the list, and this is the, yeah, this is the total number up to that, the point up to the time we are preparing this video. And you can click on the point on the dot which represents the customers. Then you can see the information filled in every field. Yeah. So if you click on the bar, it filters out the number. For instance, here we click on this date on 23, then it filtered out all this, the location of the customers surveyed, where are they available, where are they located. Yeah, you can scroll to the list as I said. Yeah, this is the dashboard for surveying. Also, we have, as I said, the connection workflows, the new water connection workflows. It starts with the survey. So these are the dashboard, especially specifically for front office. So when a customer comes and, yeah, when a customer comes and complains for the new connection, if it takes too long to be connected, so it's easier to track them by using this dashboard instead of forwarding them to the respective unit or department. Some of the cases will be being solved at the front office. So these are the customers, the total customers up to the point we start up to the time we started this presentation. We had 706 customers who are waiting for payment. And waiting for payment, it means the customers who are already surveyed but not yet paid, whether they are waiting for invoice or the invoice was too, the new connection was too expensive, they didn't afford to pay. And here are customers who are already paid but not yet called for material pickup. And these are customers who are already picked up the materials and not yet connected, waiting for some reason, they are waiting for connections. So these are the lists. You can scroll to the list, but because it's a picture, it's not possible for here. Maybe during demonstration, we have a short video after here, after this slide. You can scroll to the list. And for these who are waiting for payment, in green, in orange dot, as I said, orange means surveyed, and this, the waiting for material pickup, it means the yellow dot, it means they are surveyed and paid, already paid for connection. So they are waiting to be called for material pickup. These are waiting for connection, the customers who already paid and waiting for connection. These are the total number of customers connected, and these are, this is a map. So if you click on this, you can filter out, and you can see it starts to pop up. It pop up when it starts to bring. So these are this is a dashboard for new connection workflows. So new connection steps. And here is a short video to demonstrate what it is. Yeah, to demonstrate how this dashboard works. Yeah, this is the numbers the indicator, the numbers I was saying. You can scroll from the list, you can search from the list. So if a customer comes and they want to see exactly where the connection is stuck, they can search from the dashboard, and it finds a customer and opens the details. So there is a field to fill in the remarks. Suppose the customer is not connected because maybe the customer was not picking up the phone during the connection, or a customer didn't come to pick the material, but they were sent the request to come and pick the materials. So it shows where are the connection delays. This is the another dashboard. We have a lot of dashboards. If it's only to present dashboard, I can even spend a day to present only dashboard, AUWSA dashboards. But we picked the only important dashboards. So this is the dashboard for new water connection to the low-income areas. We have a project for low-income areas, for low-income earners. So it shows the number of connected today. This was yesterday. We had 0 connection at the time we were taking this this photo, and the total for this week is 47. And here is the plumbers who are contributing to this connection, who are doing the connection. As you can see here, HOEC is leading over 25, and Samson is below 25. This is the list of already connected customers, especially this week. And here is the customers, the connected beneficiaries, because it is the project for low-income earners. So the low-income earners are beneficiaries. So this is the connection, the connected number of connected beneficiaries per ward. So every ward shows the number of connections. For here, you can see this is the leading word, and this is the least word connected. The connection still continues. As I said, because it is a project, it has a target. So the target, so far we have we have 2008-9, we are at 72%. The remaining beneficiaries to be connected is 815. This is a dashboard, as I was saying, a dashboard for the combined different dashboards by using web application and story map. So Lillian can take us through these dashboards to present this. Because her role is NRW coordinator. So for leakage, because it tells only on the leakage part. So for leakage, as an NRW coordinator, it's good to present. Welcome, Lillian.
Thank you. As my colleagues say, my name is Lillian. I'm an NRW coordinator. And here we see the use of story map and web application. As we said, it combines dashboard and the complete analysis. For this video, we can see we have a video who shows a different dashboard, and it shows the leakage overviews, ArcSan overviews, individual ArcSan, and the leakage per zone, and analysis by components. So as we can start, we can see the leakage in this year, which are already repaired, and as you can start, you can see the leakage which are active. We can see the ArcSan, which are categorized in different zones, and we can see the number of leakage which are already repaired. And also we can see at the down, we can see the leakage repaired in last 30 days. As we can see, on each days, it shows how many leakage repaired and how many leakage are still leaking as they are active leaking. And here we can see the map which show the leakage reported and the leakage repaired. So if you click, if it is click on one dot, you can see who reported in what area, what material, and who report it, and is it repaired or not repaired. So as here, you can click for one plumber to see in which location he doing for leakage repairing. We click for one artisan, and it shows which area he deals for leakage repairing. And you can see the notice here is doing the work of leakage repairing from this here. And so we can click to another plumber to see in what area he can still doing his work. And here we can see where is it located, and we can see how many leakage he has repaired. As we can see on the map, we still have the dots in different colors. So when we go to artisan overviews, we can see the plumber performance for this here. For this here, we already repaired 22 and 15 leakage, but average for plumbers, you can see 66.45 per plumbers. And here you can see plumbers who were total number of leakage per this year. And here it's individual artisan analysis. So you can see the total repaired per artisan. And you can see here you can choose who you want to see as artisan who repaired the leakage. So when you click to one, it shows the total of leakage repairing starting on 2021. And here you can see who reported on that area. You can see the different reporters as the dashboard shows. And on the map, you can see the area where the artisan repaired those leakage. And on another dashboard, which are also combined on this stall map, you can see the leakage repaired per zone. In our utility, we have different zones, and also we have DMWs in our area. So here you can choose the DMWs to see how many leakage are repaired and how many artisans are responsible for that DMWA. On the map, you can see also the dots of the leakage which are already repaired and the leakage who are still active. And the leakage who are still active. And here you can see how many artisans and are responsible for that DMWA, and also how many leakage they are repaired since this year started. So as non-revenue coordinator, I can have overview for this combined dashboard, how we can deal with non-revenue and how I can assist in which network part we can replace the pipe, or on what area we can motivate the plumbers or the artisan what to do their work in their site, and the all management in our utilities, they can see in which zone we have many active leakage and the already repaired leakage. As we can see on this side, the green one shows the active. The green one shows the repaired leakage and the red one shows the active leakage. As we can see, the zone one, it's the area where we can improve ourselves as a utility to replace some pipe and to put another pipe which can stop or we can reduce non-revenue water. Welcome back for continuing.
Yeah, thank you, AUWSA coordinator. Yeah, in summary, this dashboard, this combined dashboard helps very much the middle managers and Lillian as a AUWSA coordinator. Yeah, again, as I said, we have so many dashboards, but because of time, let's switch to web application. This is the web application, especially for viewers. as you can see from here, this AUWSA viewer, and this is specifically to those who have limited GIS knowledge. As a viewer, they cannot, yeah, ruin anything. They cannot delete anything. So this is the viewer license and viewer flow in web application. For web application, regardless of the knowledge we are using here, regardless of the knowledge of GIS for the managers and middle managers, and yeah, and the auditors. This is used for auditors and other middle managers who has limited knowledge of GIS. This is accessible in mobile application, in desktop, and in tablet. So when the auditor is at the field, because for procedures at AUWSA, after the engineering work is done, so because it requires payment, the auditor should verify what was done at the field, if it matches with the request of the material, with the request of the money for implementation. So instead of taking the hard copy, again, instead of taking the hard copy, the paper, the printed out map, they go with the tablet or smartphone and start to verify if they stand, so, and start to measure, for instance here, to verify the distance, you can measure, and they are doing to measure the distance, the length of the pipe, to verify if it was really, it matches with the request. And if they do click on the respective asset to see the pop-up. Then in the pop-up, there are information on that, asset, and to verify if it matches with the, if it matches with the asset on the ground. Now future GIS, where we want to be in the coming few years, in the coming few months. We want to explore GIS, to use GIS at call center, though the GIS knowledge is limited, and you can understand the GIS at the call center, they have to use GIS in the building, in the office, instead of having the current location in the field, but they use GIS in the office. From the office, they have to pinpoint what is happening at the field after a customer or a citizen calls. So they have to pinpoint exactly, at least near the location of whether the incident or the leaks occurred. So that requires the high skill knowledge. So we want to implement that, though it requires more training, considering their background at call center. They have limited knowledge of maps and GIS, but we want to implement that. Use GIS in controlling water rationing. For some of the areas, we are still saving by water rationing. So we want to use GIS in water rationing. Well, if a plumber closes a valve, then they have to change the status to see to close and open valve. So when a customer calls at call center to complain for no water, the first approach at call center, they have to look from the map to see the nearby valve if it is closed or open. Also, solving customer complaints. Actually, we have started at the front office using the dashboard for connection steps, but we want to do it more at call center level to solve most of the customer complaints, especially the technical complaints. We want to use, actually we have started but not much, to use GIS at water quality sampling process through ArcGIS. For now, we have the sampling points. using in GIS and collector, but we want to go more on, yeah, on water quality issue. For the, as I said, for the discussion part, if it's possible for you, Biko, to lead the discussion, because we really also really want these areas of like, not like improvement areas of, yeah, to have the quick